Now we're going to tackle one of the most difficult soldering jobs, and that is using our soldering iron to attach to these 25 mil center leads on this particular chip. Now, some of you may recognize this. This is the FTDI chip that's used as the USB to UART interface on a lot of the common microcontrollers that don't speak USB directly. We look at that part, we've got a whole bunch of really closely spaced leads here, and we're going to have to solder the part to it. First thing is, where is the index pin? Where's pin 1? And you can see there's a little indicator right there. Personally, when I do a footprint, I like to have the indicator outside, and if you look closely, look, there's another little mark corresponding to pin 1. That way, once the part is down and it hides that indicator mark, we can still see on the outside that, and that's how we're going to orient it. So let's grab our part. There's pin 1. Need to rotate him around. And again, we're going to do this just like all the other parts. We're going to just check the footprint, make sure he can fit. And the answer is yes, he can. That's great. And then what we're going to do is, what's the secret to good soldering? Solder flux. So we're going to add solder flux all around the pads, saturate it. We're going to put the part in, we're going to line it, and then we're going to tack a couple leads down and then go around at our leisure to solder the other leads. Now, here is the other secret to soldering these really small leads. Remember, we start out about 600 degrees Fahrenheit on the soldering iron in order to get hot enough to melt the solder, but not so hot that will vaporize the solder flux quickly. We clean the tip, and then we put a little solder on the soldering iron, and we let the solder and the solder flux do the work itself. In order to get these really fine pitch parts without creating a lot of solder bridges, that's when it's really important to use a fine tip. And so I've switched the soldering iron to a really fine tip, and that's going to allow us to get lead by lead. But you notice, there's a lot of gray on this tip. What's the gray mean? That means tin oxide. And so before we do anything else, we have to clean the tip. And we outlined a couple ways of doing that, using solder paste, because of the high amount of solder flux in the solder paste, that will do it, or rosin core solder, or a little bit of solder flux all by itself. And so I'm using, my favorite is the solder paste, because that has a lot of flux and solder, and it just makes it so much easier to, at the same time, use the activated flux to remove the tin oxide and coat the tip with nice, clean, fresh solder. So I've applied a little bit of solder flux, and look, hey, the tip's cleaner. Can still use a little bit more of the cleaning, and don't breathe the fumes in. And now we've got a lot of the tin oxide removed, and we've got a nice coating of solder, and we're ready to go. So next step, we add solder flux to the board. As we got our solder flux pen, make sure it's really damp. Got a lot of solder coming out. Got a lot of solder flux coming out. We can make little puddles of solder flux on our blue mat. We come along, we coat the surface. Again, liberal amount of solder flux. We're going to add solder flux later anyway, and that little bit of solder flux is going to help us position the part and hold it in place. So now we coarsely position it, and now comes the delicate part. This is where not good to have too much coffee in the morning to do this positioning. And we're doing this just manually. If we had an instrument, that would help us do the pick and place. Doing it in a microscope helps a lot as well. So as you can see, we're pretty well aligned. We've got solder flux down on the board. And now comes the hard part. Again, we want a little bit of solder on the tip of the soldering iron, a hot soldering iron, no oxide. And now we're going to hold that part in position. And look, we let the solder do the work. So we've tacked down that lead. We're in good shape. I'm going to go to the other side. We'll do another lead. And again, can't have too much solder flux. So we're going to coat This guy here with solder flux. It's a little awkward for me at this angle because I have to reach around the camera. Should be a lot easier for you guys. If you have the opportunity, you also want to do this under a microscope. So put a little solder on the soldering iron, bring it in contact with the lead, and you did a good job of the solder flux, then the solder and the solder flux will do the work for you. And now it's tacked on, can't move that part, and now we're ready to go. And so our goal is, again, liberal use of solder flux. So we wet that surface, a clean tip, doesn't have to be very hot, 600 to 650, and then we are literally going to go lead by lead. A little bit of solder, and then we touch one lead at a time. We let the solder do the work, and if we come straight on, literally all we have to do is touch one lead, let the solder do the work. Now some folks like to add solder paste to the pads and then reflow with a hot air gun. That might work. Personally, I find just using a small tip Okay, so that's going to be the technique that we use. Again, you can never have too much solder flux down on the pads. And you can see that the soldering iron is small enough that it can touch one pad at a time. And that's what we want to do. We want to let the solder flux and the solder do the work for us. And we're heating up the lead. Just kind of drawing it out. If we make a solder bridge, that's okay. We know how to clean them up. And you can see when the solder reflows the pad, it's a little shiny there. Now, one approach is, hey, you know what? We'll just make sure that everybody's soldered. We'll purposely add a lot of excess solder here and let it reflow, and that way we are sure of making a good lead. And if we add enough excess solder, everybody is nicely reflowed, and then all we have to do is come along and suck up all the excess solder. And let's do that really quick. So what we're going to do is we're going to make a puddle of solder here, solder flux. There's our puddle of solder flux. We're going to saturate our wick in it, and look, it's just going to suck up that solder flux. We're going to use a hotter soldering iron. And again, this is where using a wide tip is perfectly fine. We're going to put the solder flux, put the solder wick in contact with the pads, and then we're going to let the solder wick, the high temperature, and the flux do its job. And it's just going to suck up all that excess solder. Remember, what's the secret to sucking up excess solder? Is solder flux. And look, we're already sucking up that extra solder. Solder wick is cheap. When you get it saturated and full of solder, cut it off, start fresh, and again, saturate it, let it soak up all that solder flux. If you hear it sizzling, you know it's working. Now if you notice, here's the hot soldering tip. I'm bringing it in contact with the solder on the board and I'm just not getting anywhere. It's not even melting the solder over there. It's a combination of two things. One is the tip has tin oxide on it because it's hot, and there's a lot of thermal mass. And so this is where, again, the solder flux is going to help dissolve that tin, and I want to bring it in contact. Okay. There we go. Wow, look at that. Okay. Get rid of the bad solder wick. Solder wick is cheap. Don't hesitate to use as much as you need. And again, what's the secret? The secret is using it saturated with solder flux. And look what happened to the solder wick. You can see the silver color there. It's all the solder it sucked up. Very simple method. And we come along, and again, we're just sucking up the excess solder. Wow. And that looks great. Okay. Never be afraid of making solder shorts. If you do, you know how to clean them up. Now, if you look closely at the leads, I'm looking here, and I'm a little suspicious of this one lead. There's a guy. I'm not sure these two have gotten a good solder. So I'm going to just add a little bit of solder flux and solder them again. And then I'm going to make sure that we get a good solder joint on these guys. And again, because I have the large tip, we're going to clean the solder off. So let's take a look and see how good we did on those leads under the microscope.